So let's do a basketball player problem. I have a basketball player. And my basketball player is going to be 65 kilograms. And so we could draw our free body diagram for this. This is going to be my normal force. This is going to be my force due to gravity. And our basketball player is going to jump up with a velocity equal to 1.8 meters per second. We want to calculate an impulse. We want to calculate the force on the floor. And we want to calculate the total average force if the player is in contact for 0.45 seconds. So remember that our impulse is equal to a change in momentum. So our impulse is going to equal the mass velocity final minus velocity initial. And our mass is 65 kilograms. And our velocity final is 1.8 meters per second. Our initial velocity is 0 meters per second. And so our impulse is going to end up being 117 kilograms meters per second. We want to calculate the force on the floor, or the force of the floor on the player, or the other way around, either way, because this is basically, this is my force due to gravity. This is my normal force. This is going to be mg. We know that our player is 65 kilograms. 9.81 meters per second squared. And that's going to give me 637 newtons. And if we do the force of the floor, that's going to be up. If we do the force of the player, that's going to be down. So this is the force for the floor, force for the player. Now that's just if they're standing there. Okay, that's just if they're standing there. But if we want to know the average force, we can use our impulse is equal to our change in momentum. That's force times my change in time, which is equal to my change in momentum. We already figured that part out. That was 117 kilograms meters per second. And now my force is going to be that divided by my change in time. And this will be over seconds. So I'm going to be in newtons. So that's going to work out really well. And we said our change in time was 0.45 seconds. So this is going to work out to be 260 newtons. So that's the force of the jump. And this is the force due to the jump. And if I want to look at the total force, that's going to be the force due to gravity plus the force due to the jump. And that's going to be 260 plus 637. And that's going to be 897 newtons. So that's kind of a fun problem to look at. We're going to do a glancing collision. So I'm going to take a ball that is 0.2 kilograms. It has a velocity of 2 meters per second. It's going to hit another ball, and it's going to be 0.3 kilograms. And it has a velocity initial of 0. And after the collision, this is the 0.2 kilogram one. It's going to go off at 1 meter per second. And it's going to go off at an angle of 53 degrees. We want to know which direction this one goes off. So we want to find the angle and the velocity. So this is a two-dimensional problem. We still have the momentum before. Has to equal the momentum after. And we know that the momentum in the x direction is independent of the y direction. So I'm going to go in here and I'm going to get this. We're going to get, this one is going to have an x component and a y component. This one's going to have an x component and a y component. And if I do this one, this is going to be my v.3. X is going to be v cosine of my angle. My v.3 y is going to be minus v sine of the angle. This one, v.2 x, is going to be 1 meter per second cosine of 53 degrees. And v.2 y is going to be 1 meter per second sine of 53 degrees. So we've got our, I'm going to move that down so that you all can see it. So we can break it up into our two components. So we got to start with our x's and our y's. So let's start with our x. So the momentum before in the x direction is the mass of my 0.2, velocity 0.2, plus 0, because the velocity of 0.3 was 0, and that's going to equal mass of 0.2, velocity 0.2x, plus mass of 0.3, velocity 0.3x, cos, or 0.3x. So we know that this is 0.2 times our 2 meters per second. This is 0.21 cosine 53 degrees plus 0.3 v cosine of the angle that we need to figure out. So I'm going to go ahead and solve for v cosine of our angle here. So this is going to be, where's my calculator? There we go. 0.2 times 2. This is going to be my 0.4 minus 0.12 divided by my 0.3. This is going to be 0.93 is equal to the velocity final cosine of the angle. So now we got to do the other one. Well, the initial momentum in the y direction is 0 because we started with nothing in the y direction. We only had an x direction. That's going to equal my 0.21 sine of 53 degrees minus my 0.3 v sine of my angle. So v sine of the angle is going to equal gives me 0.53. So I've got this one and that one, and I've got two equations, two unknowns. So I'm going to do a little mathematical trick. I'm going to do v sine of the angle divided by v cosine of the angle. And that's going to give me my 0.93 divided by my 0.53. That cancels. This is the tangent of the angle. It gives me 1.75. My angle is going to end up being 60 degrees. And now that I have that, I get v sine of my angle is 0.93. Oops, I have this reversed. V sine of the angle was 0.53. V cosine of the angle is 0.93. Which means my angle is actually 30 degrees. And this is going to be 0.53. So V is going to equal 0.53 divided by the sine of 30 degrees. And I get 1.06 meters per second. That gives you a little bit different viewpoint on how to work a glancing blow problem, and it kind of reviewed our collisions. It reviewed our collisions as well as helping us with a two-dimensional problem. Question.